Now I have drawn this phasor in phase with this. Now JIR into X. This IR into X means it is a scalar quantity multiplied by G. It means J into X when multiplied by I will be a phasor which is perpendicular to and ahead to IR. That's why it will be like this. And you know that the voltage drop, the voltage or we can say current in an inductor lags beyond its voltage by 90 degrees. That's what this means. If I put it over here, you will see that this current is lagging to this voltage drop by 90 degrees. Then Vs will be the phasor sum of this plus this plus this. This will be the complete Vs. Now here I will first draw this distance from here to here, and you will see that this triangle will be a right angle triangle, and this part, this length will be its cos component, and this length will be its sine component. That means this length will be Vs cos of delta, Vs cos of delta from this point to this point. Let us call this point as P and this point is O. This I mean to say the length OP will be equal to Vs cos of delta in terms of Vs and in terms of delta. If delta is very small, close to 0, this cos delta will be close to 1, and that means Vs cos of delta will be close to Vs. So this distance will be equal to this Vr, that is this distance plus this distance plus this distance. It will be equal to IR, and this distance will be in this triangle cos component of this phasor, and this phasor is equal to IR into R. So it will be equal to IR into R cos of theta, and this distance from here, you will see that in this triangle, since this is theta, same theta, in this triangle it will be equal to this length, and this length will be this sine component of this phasor, and this will be equal to IRX into sine of theta. Here J will not come because J, we are only taking the magnitudes in consideration, because J means a shift of 90 degrees that has already been taken care of. So finally this VR, that is percentage voltage regulation, is equal to Vs minus Vr. I will take this here, it will be minus Vr, and then divide the whole equation by Vr. It will be equal to IR. I will take IR common from here and here, R cos of theta plus X sine of theta. This is the approximate voltage regulation, because in this case we are assuming this distance to be equal to this distance. We are not actually calculating the Vs, we are calculating its cos component. So when delta is equal to 0, it is a good approximation. Not 0, close to 0, it is a good approximation. But when delta goes beyond some value, it is not valid in that case. I will come to that case also. So coming back, when R is equal to 0, this VR is equal to, in this equation R will be equal to 0, this voltage regulation will be equal to X IR by VR X sine of theta, IR by VR X sine of theta. Then for voltage, percentage voltage regulation is equal to 0. This happens only when, from this equation, when theta is equal to 0. That means at unity power factor. At unity power factor. I'll come to this. You will, when R is equal to 0, this equation will reduce to this value. This equation will reduce to this value, because this term will be 0. It will be equal to VR plus JIR into X. So I have deliberately kept it like this, incomplete. Now when this R is equal to 0, that means this voltage drop will be equal to 0. Now this phasor, this voltage drop J into Ix will not be over here, it will be at this point. Now it will be like this, definitely parallel to this, and this will be now our Vs. This will be J I into X. This will be Vs. You can see here that this delta dash is now greater than delta. It has gone beyond the limit. That means when R is equal to 0, this approximation is not valid. This approximation is not valid because delta has increased now, and in that case Vs cos of delta, we cannot assume it to be equal to Vs, because it will result in erroneous values. So when R is equal to 0, our circuit will look like this. Now I have told you that when if I have used this formula for voltage regulation 0, it comes out to be theta is equal to 0, and it means unity power factor. When we draw the phasor diagram for this case at unity power factor, this is VR and IR will be in phase with this because of unity power factor, and this will be J IR into X, that's voltage drop across this X. You can see from clearly that Vs is quite greater than this VR, and delta is very high. Delta is very high. In this case, voltage regulation cannot be equal to 0, which we have derived from the equation, approximate equation. That means in this case, this approximate equation is not valid. So we need to derive an equation for this case when R is equal to 0. When will this will be equal to 0? So I have in general told that we can generalize it that when R is equal to 0, this approximation or approximate formula is not valid. So we will derive another formula for this. For 0 voltage regulation, Vs should be equal to VR, isn't it? For 0 voltage regulation, Vs should be equal to VR. We know this. When Vs is equal to VR, that means in short transmission line, that means this Vs is equal to VR, VR is equal to nominal voltage. This will be equal to 0, voltage regulation will be equal to 0. I will show its phasor diagram over here. I will redraw this. This is VR, this is IR, this is IS, and this is Vs, and this is X. So in this case, this Vs is again equal to VR plus J IR into X. Of course, these are all phasors, and we always take VR as a reference. Let us say this is VR. In this case, we don't know where the value of or where IR lies or what is the power factor of the load. We only know that Vs is equal to VR. One thing you should be clear that when this is the case, when this is the direction of the power or current, that means power flows from sending end to receiving end. So when we draw Vs with respect to VR for power so that it flows from sending end to receiving end, Vs has to lead VR by some angle delta. So this is the usual case which is happening in the transmission system. That means we are drawing this Vs at an angle of delta leading to this VR, assuming that power is transferring from Vs to VR, or we can say from sending end to receiving end. And now for voltage regulation equal to 0, this Vs, that means the length of this Vs or length of this VR, they should be same. They should be same. Now to hold this equation, that means KVL in this case, this must be the voltage drop, that means this J I R into X. Since these two are the equal sides, this angle and this angle will be same. This is one thing. I will come to this. Now I have to see where this IR lies. I will draw this like this here. This is J IR into X. This is the voltage drop across this. Current will lie or current will be lagging to this voltage drop at 90 degrees. That means this will be like this. I'll first draw it over here. This will be IR. This current, it will be lagging to this by 90 degrees. Now actually we always draw this V or IR, that means its tail and the tail of VR, we usually coincide them. So I will draw it over here. This is actually IR, and when I extend it to this point, you'll see that since this is perpendicular, this will be perpendicular to this in both the cases. So this is, if we see this triangle, this will be an isosceles triangle. These two sides equal. these two angles equal, and this is the perpendicular. When this is a perpendicular, it will automatically be perpendicular bisector to this side. That means this side will be equal to this side. It will be a bisector to this. Now coming back to this, when this is bisector to this, you will see that this is equal, this is equal, sorry, this is equal to this is equal to this, sorry, this is equal to this, and this is the common side. These two are the congruent angle. That means this angle and this angle will be same. Since their sum is equal to delta and they are equal, this means this angle will be equal to delta by 2. This is actually a power factor angle. So power factor angle theta in this case will be equal to delta by 2. This is one thing. I have actually drawn the same over here. I redraw it just to make it sure. Now what I mean to say is that this angle, the power factor angle, will be now equal to, that is cos of, sorry, theta, that is power factor angle, that is angle between IR and VR, will be equal to delta by 2, where delta is the angle between VS and VR. Now this is clear. From this triangle you can see it, this is the perpendicular, this one. Now for delta by 2, this will be the base, this will be perpendicular, and this will be the hypotenuse. So we'll calculate sine of delta by 2. Sine of delta by 2 will be equal to this perpendicular divided by hypotenuse. Perpendicular will be the half of this, that is IR into x by 2 divided by this VR. This will be sine of delta by 2.